Good evening and welcome to the 10th Annual Albert A. Hopeman Lecture Series. Albert A. Hopeman, the purpose of my just brief remarks, Dean Birmingham will introduce our speaker, is just to say a few words about Mr. Hopeman. Al Hopeman was born in 1911 and was educated at MIT, graduating in 1934. He entered the family business, Hopeman Brothers, and then AWH, the holding company, one of the leading private companies in America in three different areas, technology related, and also building the interiors of large ships. For you Grovers that are out there in the audience, Mr. Hopeman's both father and uncle became very close friends of Mr. J. Howard Pugh when Mr. Pugh was chairman of the board here at Grove City for so many years, and also was president of Sun Oil in Philadelphia. During World War II, the Sun Oil Company had the fourth largest, although it was unarmed, largest navy in the world in World War II, and it was the tankers and all the carriers that delivered all of the petroleum for the war effort, for the Allied effort. And Mr. Hopeman's company did all of the ship interior building and outfitting of those great ships, and that's how the Hopeman family and the Pugh family became so close together. Mr. Pugh brought Mr. Hopeman to the Board of Trustees in 1953, where he served for 47 years. And when J. Howard Pugh died in 1971, he had been on the board for 59 and a half years and had been board chairman for the 40 years prior to his death. Mr. Hopeman was the vice chairman of the board and ascended to the chairmanship of the board, where he served until his death in 1998. A wonderful gentleman. Just before his death in 1997, the trustees of Grove City College named the Hopeman School, the School of Science, Engineering, and Mathematics, the Hopeman School of Science, Engineering, and Mathematics. And we proceeded with the sponsorship of the Alumni Association of Grove City College to present on an annual basis the Albert A. Hopeman Lecture. With that, let me introduce our Dean of the Hopeman School, who will introduce our distinguished speaker tonight. Dean Birmingham.
I'm very pleased this evening to welcome Dr. Bob Colwell as our Hopeman lecturer. Got to know Bob back in graduate school at Carnegie Mellon and sort of followed his career since then. You can all thank Bob for the tablets that you have today. He was the chief Pentium microprocessor architect from 1992 to 2000 through Pentium 4. Is that right? Through the Pentium 4 process. He was named the Eckert-Mauchly Award winner in 2005 and was elected to the National Academy of Engineering in 2006 for his contributions. Dr. Caldwell was also named an Intel Fellow in 96 and 2006. He also worked at some other companies along the way, including Multiflow Computer, Perk Systems, and Bell Labs. Bob has his undergraduate degree from Pitt. In fact, he grew up in the South Hills of Pittsburgh, and his graduate degree from Carnegie Mellon. So I'll turn it over to you. Thank you.
Thanks. First, I want to thank you all for inviting me to come and speak. It's quite an honor, and I had a great time putting this talk together, especially because I accepted the speaking gig before the Steelers won the Super Bowl, most recently, and so it was kind of fun to work in lots of fun references. In fact, one of them, I do a fair amount of legal expert witness work now, and one of them takes me to Dallas a lot. And in Dallas, they'll give you Coke cans that have their 5 Super Bowl rings around the top of the can. And so I always commiserate and say, sorry guys, I hope you can do better. And it's really fun to tell them that. So first, I wanted to explain this opening screen just so you can sort of get a gist of where this is heading. Across the top are 4 instances of things that I consider stellar engineering. And you'll notice that even though I'm a computer chip guy by career, I try reasonably hard to draw lessons about engineering from wherever I can find them. And I don't observe boundaries, just because it's not just the computer science industry that interests me, it's engineering in general, because I think you can learn lots of cool lessons from areas that are outside your main area of concentration. The lessons are universal. There's aspects of engineering that, if you get them right, you can apply them no matter what kind of engineering you end up doing. My favorite example is the one at the top left, which you might recognize as one of the Mars rovers. If you haven't been paying attention to those things and you're at all interested in science or engineering, I encourage you to take a look because those are unbelievable. Those guys designed those things for just a month or about a month of operation on the Mars surface, and they're both running 5 years later. It's unbelievable what they accomplished with those things. So, if you want to see what incredible engineering looks like, that's People's Exhibit A. The second thing in, you might recognize those airplanes, but you might not recognize the guy. That's the smiling face of a guy named Kelly Johnson, who designed the U-2 spy plane and then the SR-71 Blackbird. And that Blackbird airplane, he designed that in the 1960s with no computer support and no modeling at all. And it still holds the world record, as far as we know, for a military aircraft. I say that carefully because who the heck really knows, right? And if you're a paranoid type, you might go other places with that. But there are books out on his life if you're interested in general engineering, how to do this right. Take a look at what he did. His level of attention to detail was incredible. He was also a pilot, and he was a contemporary of Howard Hughes, who he considered one of the worst pilots on the planet. And they just didn't like each other much, which cracks me up every time I go to the McMinnville Air Museum in Oregon. They've got the Spruce Goose, that gigantic wooden plane that Howard Hughes built, and they've got an SR-71 parked under its wing. Literally. Every time I look at that, I think, boy, those guys would have loved to see that. But anyway, Kelly Johnson did a heck of a good job on those airplanes. He was a genius designer, but the reason I think it's worth noting what he did was his level of attention to detail was all the way down to the electrical connections inside the wings, because he knew that a lot of times in an airplane, you have to do maintenance on things. You unplug them and you test them and you plug them back together. And if Murphy being what he is, if you plug them back together and you can get them wrong, somebody will. And then if you can take off that way and the plane doesn't fly properly, you can have a real problem. That's one of the reasons why pilots always waggle the tail and things before they take off, just to make sure that at least something's working before you get off the ground and into trouble. And what Kelly Johnson did was he made sure that all the connections could not possibly be miswired. He specifically made them so that they were different mating surfaces, different size, different numbers of pins. You literally couldn't get them wrong. And that was his insight that that level of detail was required. He also figured out how to drill holes in titanium, which no one knew how to do back in the 60s. Instead of getting 100 holes per bit, they were getting 1 hole per bit because titanium is really brittle and very hard. Anyway, he worked his way through all of that stuff and gave the U.S. An amazing platform for surveillance. And it was him. There's really no doubt that he was the prime mover on that. I think the Brooklyn Bridge is a cool thing. I can tell you as a chip designer, the day after your new chip comes out, you're a hero. And this literally happened. My third grade son came home one day, a couple days after our first chip came out, and said, my friends think I'm great because my dad designed this, this computer chip. And I said, that's nice, son. Of course, I was acting like it was no big deal, but it was pretty cool. 6 months later, I was in the doghouse because another chip had come out and it was faster than ours, and my son wouldn't speak to me about this anymore. It's like the thrill was gone. But if you look at something like the Brooklyn Bridge, you get it right, it sits there for 100 years. I think that's a pretty cool engineering achievement, and I also like the fact that they took care with the aesthetics of the thing. It's not just a matter of keeping the cars from getting wet when they go across, right? It has to look nice. People have to put up with it. It's in their neighborhood and that sort of thing. And then on the right, I encourage you to, at some point, if you have any interest at all, take a look at what's inside cell phones, because you'll be amazed at what's in there. I'm appalled when I see things like, I sometimes worry about your generation. My son is approximately your age. And I had a bunch of his friends over at our beach house one time, and they had one of those clamshell, like this phone is a clamshell case with a spring loaded in the hinge. And his friend was taking his phone and seeing how high he could drop it off the desk so it would bounce back up. He goes, and the answer was about this far, because if you go this far, it explodes. And what I was thinking was, do you have any idea what it is you just broke and how it works? Or, when I was your age, we listened to music on these things that spun around with a needle. And if you weren't careful, you would destroy the record or destroy the needle, and these were expensive, so you were careful. Technology was something you took care of. And now we're doing destruction testing of them, or what? What do you guys, I don't trust you. Anyway, there's cool stuff in there, and I encourage you to find out what it is, and to see what really good engineering looks like. And then we come to the Steelers, and you're going to see a lot about them as we go along, and that's why I stuck them on the cover, just because I like them. So one of the things we're going to talk about is some touchy-feely stuff that they don't normally tell you, especially not in engineering school, where even if you're female, you're supposed to be somewhat macho. You know, there's this engineering thing, I don't care what the world says about me, you know, I'm smarter than them anyway kind of thing. And while it may be true, you have to be careful with it. And so we're going to talk about kind of the boundaries of that kind of attitude. And I'm going to throw in some inspirational thoughts, not necessarily of origin starting with me, but I'm warning you, I'm just going to throw them in there because I couldn't see a logical way to put them, but I wanted to tell them anyway. So you're going to see them. And don't worry too much, it's still macho because there's lots of Steeler references. So first, this is important. Don't believe everything you hear except for this talk. And so People's Exhibit A, until 1965, and you know, some of us are old enough to remember this, but some of you won't, so that's why I'm going to tell you. See all those weird-looking plastic things in the picture? Those were transistor radios. And when I was a little kid in the 60s, those were what you wanted because you could turn them on and you could listen to AM radio and you could listen to the Beatles. And you know, there was actually some pretty good music, although it sounded awful. We didn't know that at the time, but it did. But the thing one of the earliest things I learned about these, of course, I was an engineer. Yes, it's a cool radio, but what's in there? I want to see how's this thing work? So I would take the back apart. And I would count the little things that had little silver cans on them. And somebody told me those were transistors. I don't know what transistor was, but I knew that I could count. And so, you know, and my transistor radio was a 6-transistor radio. And my friend got an 8. And I thought, what do those extra 2 transistors do? Why does he need 2 more than me? But 2 must be better than 6, otherwise they wouldn't put them in there, right? Well, I discovered by taking it apart and looking at the circuit board that the 2 extra transistors didn't do anything. They weren't soldered to anything. And I discovered later that they didn't even work. They were just floor sweepings. But by putting them in, they could say it's an 8-transistor radio. And I was shocked. And by the way, this game went all the way up to 8 to 10 to 12. I saw 12 transistor radios where half of them didn't do anything. And so I remember as a little kid, and of course I didn't know how anything worked. I kind of knew that if the leads didn't go anywhere, it couldn't be participating in whatever it was the radio did. But so I was shocked. I thought, how could it be that they would put something out on the market and mislead me, the consumer, in so egregious a fashion? Surely this is illegal, right? I still wonder how they did that, actually. But, you know, the interesting thing to me was these transistor radios really weren't very high quality. They were pretty poor. I mean, I don't know how they soldered them, but it looked like some, you know, primate did it on. I mean, it was luck if it worked. And so it was made in Japan. And back in the early 60s, made in Japan meant junk. It was synonymous with junk. All right, let's just call a spade a spade. But the thing was that Japan kind of knew that, and that wasn't their goal. That was just them getting started. After a while, by a mere less than 10 years later, when it said made in Japan, it meant really high quality. You know, stuff that you to seriously take as a contender for the best we could do. And so Japan specifically and pointedly and purposely targeted some of our markets, for example, motorcycles, and said, I want that. And we're going to organize ourselves so as to go after it and take it. And they did. And they took color TVs, and they took stereos, and they took car radios, and they took a lot of stuff. And the problem was that as an undergrad EE in 1973 at Pitt, they were telling us, you know, there's no real point in going to electronics because the Japanese are doing those. And they haven't done computers yet, but, you know, who knows where that's really going to go. And besides, they're going to take that too. There's no point. So just find something else to do. And I was really sad as a result of that, because I liked electronics and I thought computers were kind of cool, although I didn't know how they worked or what they really did. I just knew my revelation moment was I went to visit Pitt to visit a friend when I was still in high school, and I was standing next to some machine which I didn't know what it was, and suddenly it started going. It was a printer, and paper was coming out and stuff was printed on it, and I stood there in astonishment thinking, how did they do that? You know, what's this thing doing? I want to know what's in there. So I really wanted to work on this, but I didn't speak Japanese. At that point, I didn't like Japanese food, so I was seriously handicapped, and I figured I'd have to do something else. And this is what was being fed to us by, you know, even at Pitt. It was, you know, even at an engineering school, they were giving us this, gee, your future looks pretty grim. But this was also Pittsburgh in the 1970s, which, by the way, that picture's not Pittsburgh in the 70s, otherwise it would just be all gray. And it was, you guys may not remember that, but I stood on my porch at my parents' house once, and I went like this and could not see my finger. I mean, it was the air was sometimes extremely bad. My dad, of course, would say, hey, that means the mills are running. What's wrong with that? And I said, okay, there's something to be said by that. Can't you clean up a little bit? But the other aspect of Pittsburgh, besides cleaning up the city, was the Steelers used to really stink back in the 60s. I went to one Steeler game in 1968, and it was really embarrassing. I mean, it was pathetic, really. And they were striving not to be the doormats anymore. And I want you to know that that is Steeler font. I went to the internet and found that for you guys so that it would be more authentic. So it's actually called Gunplay, in case you want to use it for your class assignments. So the question was, what would Jack Lambert do? Now, do you remember Jack Lambert, you guys? I mean, this is an actual unretouched photo of. There's a bunch of quotes on the Steeler website, and one of them is from John Elway, and he said the first time he played in the playoffs against Jack Lambert, he said this big slobbery guy came after me and creamed me, and he said I wanted to give all the money back and quit football. And I went, yep, that's Jack Lambert. And the thing was that I noticed was even though they weren't really good yet, they never quit. They never went down without a fight. And what Jack said was, the Steelers were always trying to replace him, but they never could. And it wasn't because they weren't finding people that, at least on paper, looked like they should have. It's because he was bringing something else to the game. So I figured, if Jack can do that, and Japan wants to take computers, let them take it, but they're going to do it with a fight. We're not just going to give it to them for free. So how do you go about doing that? Well, if you want to see how the Steelers did it, I assume some of you are Steeler fans. Let's at least agree they're not the flashiest team, right? In fact, sometimes their running game is kind of like, a little bit dull. I love the defense, even though it's also kind of dull sometimes, but I just love watching them sack people. But the cool thing, and the thing I want to draw your attention to, is their attention to detail. That is what they do better than anyone else. When you see someone needing tackling, you don't see one guy tackling unless it's Polamalu. Normally you see all 15 Steelers, even though there's only 11 on the field, all tackling him at once. They never quit. They might get knocked down, they get back up, they chase the guy. So channel your inner Polamalu. And the other thing I wanted to point out was, yeah, they've won Super Bowls, and there's been some really incredible plays, including this one. But the thing to notice is that's not how they got there. You've got to get into the Super Bowl before you can do the flashy play. How do you get to the Super Bowl? And my message to you is it's the fundamentals. You have to compete on the fundamentals, and that's what they do the best. And the other aspect is when you do get beaten, sometimes you will because there's competition and other people are smart too, you have to figure out how they did it. It's really important. Figure out what they noticed that you didn't before, what technique did they come up with that was never done before. Learn from it and do it better. You don't just walk away and say, darn, they're smarter than me, I guess I better go back to the fries. Instead, you say, I noticed what this new play that they came up with beat me. You also notice even in Steeler games, by the way, at halftime, they often come out and they will have adjusted for what was happening in the first half. If the other team was doing something that kept on working, it's not going to work in the second half. Maybe something new will, but that old technique won't because they're paying attention and they're learning as they go. We have to do the same thing in engineering. So, as of right now, at least in some sense, the U.S. still owns computers. And by the way, I'm not saying I did that. That's just the way it's turned out. But I do want to point out it's not for lack of trying. Other countries have purposely attempted to take this whole industry away from us multiple times. Japan's done that. China's done it. Korea's done it. Taiwan. They're having trouble. It's not because they haven't tried. And I want to point out those laptops you lug around. Most of those, they're almost all foreign parts, except for the computer parts, except for the microprocessor and the chipsets. I think, and this is a message to our congressmen, I think it helped a lot that our universities, our colleges are still drawing the best in the world. But the key thing is once we've educated people to be as smart as we are about technology, don't force them to go home, for heaven's sakes. Let them stay here and help us. If you let them go home, they're just going to compete with us, right? So one of the cool things that we were doing back or that were happening in the 70s, 80s, and 90s was where the best students would come to this country, we would educate them, and then they would stick around and join our design teams. A design team like Intel, I would say 2/3 of it are Indian, Chinese, Arab, lots of people from other countries. It takes guts to pull up your stakes and move to another country, right? And you have to be a pretty darn good student to get sponsored to do it in the first place. So you're already a couple steps ahead. Once we've educated these guys, I want them to stick around. So now after all of this, the Steelers have 6 Super Bowl rings, and I don't think it's a coincidence. So here's one of the insights I promised you. Isaac Asimov said, science can amuse and fascinate us all, but it's engineering that changes the world. I thought, I like that because I'm an engineer. I also like science, by the way. I don't have any gripe about it. I do like to hammer on engineering a little bit because I think, at least in the public's mind, when they think of anything complicated, they say, oh, it must be science. But if they think of something that broke and didn't work right, you see where that's going, right? So I'm not happy with that, and I'm trying to redress the balance. So, Linus Pauling, if you want to be an engineer, I think this is as good an idea as I've heard. The way to get good ideas is to get lots of ideas and throw the bad ones away. And we did that many, many times, especially at Intel. We would get a room together. We'd say, look, this is the problem that's stalling progress. This is something we have to nail down. You can't do this with too many people. If you have 20 people in a room, forget it. It's not going to work. But if you have 2, 3, 4, 5, and they're dedicated to trying to solve a problem, you can get a result that's better than the sum of all the people together. It can work that way. You have to do it right. But one of the keys is let them generate as many ideas as they can think of, and then you sift through them and say, that was dumb, what's this? That's what you're looking for. So competition's global. I don't deny it. I'm not going to make light of it like it's always the same as it was back in the 60s with the 8 transistor radios. And you could say it's harder. That's probably true, arguably. I think the fact that the internet exists empowers groups of people in the world to compete with us that normally would not have been able to. We've allowed that to happen because we invented the internet in this country, right? Things happen more quickly. It's becoming more expensive to make a mistake or even just to put a product out in the first place. I was mentioning this afternoon, if you do the math, if you're a chip manufacturer and you make, say, 250 million parts a year, if you had to recall a substantial fraction of those, you would become bankrupt. You can't do it. It's too much money. And yet the amount of complexity we're putting in those products goes up and up and up each time we make a new one. So you take those two trends, put them together and say, boy, this does not look pretty if you're a manufacturer like Intel, for instance. Then there's this issue about, well, when you have the internet to facilitate the information transfer, it allows people that get paid a lot less than we get paid in the United States to play the same game. For example, software creation. And so what does that mean in terms of our productivity burden in the United States if we hope to compete with that? And to which my answer is, yes, there is an issue there. But remember that the internet's only 14 years old or something. It's not, you may think that's a long time, but I don't. And also remember that we're in a transient phase. It's not steady state yet. As this outsourcing stuff happens, those other countries' standard of living rises as well. And when it does, it's diminishing the disparity between them and us, which makes us more competitive. So you have to watch out for that effect. And finally, get over it. Engineering isn't for whiners. You have to, when you put a product out in the world, whether it's a military weapon or a commercial chip or software, you've got your heart and soul in that. It's part of you, and it has to work. And furthermore, there may be people whose lives depend on your having done your job properly. Someone does have to design such things, and thank God that they do. It's important to all of us for future health care, for example, or defense. But once you've done that, you've got to stand behind it. And that's helpful in 2 ways, actually. It's helpful in the sense that it convinces you to do a really good job in the first place, if you know it's going out there with your name, figuratively written on it. But it also helps because it keeps you in the game. It motivates you to do the proper things up front. It keeps your team focused. It has the right effects. And finally, make sure that what you're really looking for is to make those other countries worry about having to compete with you. That's what you really want. And I don't see any reason why we can't do it as we've been doing it. There's a way to think about competition, and there's a way not to. I think you have to take them seriously, but not too seriously. I was at startups, for example, where you could scare yourself to death and never come back to work. You're in the middle of designing a machine, for example, in my case, and you kind of know when you start the project, you're shooting for performance that's out here. But as the project moves along, that horizon moves in towards you because you're forced to make compromises in ways that you don't anticipate. They're almost never in your favor. Like if you're running a project, you will never hear an employee of yours come into your office and say, boss, I have a great idea. It's going to make the machine 3 times faster than you thought. It doesn't cost a thing. It doesn't happen. Instead, 15 of them come in your office and they say, boss, I know I promised you this much, but I can only do 75% of that, okay? And you say, no, that's not such good news, actually. And after enough people do that to you, that you make your decisions as best you can through the thicket of their input. And what the net effect is your horizon moves in a little bit. Your chip's not quite as good as it was going to be. Your software is going to be a little bit less capable. But that's okay. That happens to everybody. The idea is to do this judiciously and make the compromises in the right place. So if you take competitors too seriously while you're doing this game, you throw up your hands in despair and say, oh, they walk on water and we're a bunch of idiots. We might as well just quit. You don't do that. They can't walk on water either. My dad always said, the reason you have to take competitors seriously is that the world doesn't owe you a living. He reminded us that a lot, and sort of looking back on it, I think he was dead right. It was his way of motivating us and saying, you've got to get out there and do something. You can't just sort of sit around and wait for the world to come bring you a big check. You also have to realize the competition will show up, and that's not such a bad thing. If you're out in the world and you're doing something and you're making some money, but you've got no competition, that means the world's betting against you. They think what you're doing is dumb and temporary. Now, maybe they're wrong, and you should keep doing what you're doing, but it's not actually a bad sign if the alternative happens and you go out into business and you start doing something and suddenly you're surrounded by competition. That means they think what you're doing is great. They want a part of it. They want to help drive it forward. It's not bad. You have to watch for competition. Don't psych yourself out, and remember that this physics is the same for everybody. It's a great leveler. But most importantly, don't ever believe your own hype. That's even more insidious than believing their hype, right? Because then you stop questioning what you're doing, and you're seriously on the road to disaster when that happens. The fundamentals are you have to design outstanding products. If you do that, everything else will follow, and it will turn out okay. If you're doing mediocre products, all bets are off. You have to be careful of that. It's a self-fulfilling prophecy. So if you're going to think about competition, I think the most healthy way that you can do it is to say, I'm going to put this thing out there. It's going to be the best that I and my team can do, and put your best out there too, and we'll see what happens. So how do you design outstanding products? Well, I think the first thing you do as a technologist is you say, I know what the technology is today, and I know how long it's going to take me to do something new. By that time, what will be the best the competition can do? What's the best the technology can do? And what do the customers really want? What would they like? What would delight that customer? And if I can find an intersection point between the technology and what I think people will want, I got a killer product. I think this is exactly what Steve Jobs is so good at with Apple. For example, when he did the original iPod, there were already, by my count, about 30 different MP3 players. Did you guys know that? A lot of people think the iPod was the first MP3 player. It was by far not. It was way late. In fact, some of us wondered what the heck Apple was even bothering for, because for example, I was at Intel the last year. I was in a group that did an MP3 player. That was in the year 2000, 2001. Now, it wasn't a great MP3 player, but it worked, and it sounded as good as Apple's thing. What we didn't have was iTunes, for one, and we didn't have the user interface. We didn't know what consumers wanted. We just made a geeky little box, right? It looked like that cell phone from the first picture, actually. So when we saw Apple's thing, we said, oh, Johnny come lately. Boy, Steve Jobs really messed this one up. Fortunately, I never wrote that down anywhere, so I can't be pinned down. But I think what he did was he said, what do people really want? What can technology really do? What's missing? What was missing was iTunes. It was a source of music that you could easily get onto the thing. When we gave, for Intel's version, we said, oh yeah, MP3 files, just load them on. This thing is, put it on your computer, it'll mount like a hard drive, copy files to it. What's the problem? Well, the problem is, my mother has no idea what I just said. People that want to just listen to tunes, they don't want to learn how to run a computer first. So this is an important one. You have to know, nowadays you can't just design something and say it's high tech, you want it. You have to say, what do customers want, and then deliver something in that general area. So here's some examples of things that I thought were done that way. The plane on the bottom left is the F-117 stealth plane. I always thought that was pretty cool of a design. If for no other reason than you'll see the little skunk below it. That's because that was designed at a place called Lockheed Skunk Works. And there's a couple books out about the Skunk Works too. You can see how those guys did business, and it was pretty cool. It was a neat place. And that by the way, that plane, there was a Russian mathematician that published an obscure paper once that pointed out that if you were doing the equivalent of ray tracing off that machine, it would be very difficult to identify an object as its real self if it was done a certain way. And the Russians didn't pick up on the implications of that, but the Lockheed Skunk Works guys did. They said, well, if that's true for ray tracing, it might be true for radar. And if that's true, we should be able to make an airplane you can't see. And that's where F-117 came from. And it's true. That thing has really low radar visibility. By the way, it's got all these angles and stuff. That's because when they designed it, they didn't have enough computer horsepower to do curves. When the B-2 bomber finally came along, it's just as low observable, but it's got curves in it because then they could do the computers could do the work required to make sure it was still low observable. Thought you'd like to know that. Tell somebody at a party someday. But not a Russian. Don't tell the Russians. I think GPSs are amazing. I love those things. I have a gift for getting lost, and they normally prevent that. Not always, but I have a real gift. That chip in the bottom right corner was mine, so it's kind of self-aggrandizing to stick it in, but I thought it was a good design. And the iPod interface, everybody seems to like that thing. I've heard some complaints about it as a phone, but as a work of art, it's beautiful. So for designing outstanding products, I just have sort of one observation to make for you, and that is when you're starting at the beginning of a project and you've decided what it is you want to design, you think you've kind of settled on the thing that's going to put it over the top for you. The way that I view that process is you have to be a certain amount of aggressive. If you shoot too low, meaning take something that's too easy, too small of an increment over what's out there now, the competition's going to wipe you out. They're going to come along with something better and the world will forget you exist. But if you shoot too high, you kill yourself. You don't even need competition. You won't get your thing working. It'll be too late, too slow, too something. So you have to shoot somewhere between those two things. That's where the sweet spot is. And you have to admit to yourself that there's a certain amount of risk you're incurring in order to hit that spot. If you're really risk averse, you can't be an engineer. You don't ever get to design the same thing exactly the same way twice. Each time it's supposed to be better. Even if you're a bridge designer, for example, you might have built the Brooklyn Bridge and said, that's the most beautiful thing I've ever created. If you want to build another one, they're not going to say, design that exact same bridge, just do it over here. Instead, they're going to say, well, that was a nice bridge. Now, can you do the same thing for 30% less money and half the time and, make it even prettier? That's more what the world really looks like. So that involves risk, and you have to take on a certain amount of risk, and it's your judgment that decides how much. Now, there's a guy named Richard Hamming. If you've ever done information theory, you've run across this guy, because he was the father of error correction coding, for example. The fact that our satellites work is directly connected to the work he did, because prior to information coding and error correction, all we knew was if you get a satellite far from Earth, the signal-to-noise ratio goes down to ridiculous depths, and you will never get that signal back out unless you've got a way of correcting the errors that will come in with it. And what he showed was you can get any fidelity you want if you're willing to pay for it, and he showed how to pay for it. Anyway, he gave a talk, and it's at the bottom of this URL at the bottom. He gave a talk called You and Your Research in 1986 and said some bunch of cool things. Mostly it was a retrospective of his own career at Bell Labs and how he came up with what he came up with. But he said a bunch of things that I thought were really worth considering, and I wanted to bring them to your attention. For example, he said success isn't just the brains you were born with. In other words, you're not allowed to sit there and say, wow, that guy did a great job, but he's just a lot smarter than me, so I guess I'm off the hook. I don't have to aspire to that. I can just sort of sit back and say, God, I'll give you back what you gave me. You're not off the hook. Because what Hamming is saying is, it isn't just the luck of the brain you were born with. It's other things as well. There's things you can do about this. This is only one factor. Yes, there are people who are born geniuses and genetic freaks, as Bill mentioned earlier. Yes, those people exist, and let's not pretend otherwise. But they're not the ones that create the products you're used to. In general, they're not. In general, the people that make the things that affect your lives and affect other people's lives are just like you. But they decided to go for it. And I'm encouraging you to think that way too, and that's what Hamming's pointing out. You have to have some courage, and you have to have an unreasonable amount of self-confidence. I always told my mother, my mother when I was growing up used to accuse me of having more self-confidence than I deserved to have. And I said, yeah, that's probably true. So what, It didn't bother me. It's like, it's better. It's better to think you're going to succeed and be surprised if you don't, because the alternative is bad. If you expect to fail, you will, right? You don't accidentally succeed at things. You have to work at it. So the other thing Hamming said, and he didn't cast it quite in these terms, but I've had this battle with my own kids who are all approximately your age, and said, you are very proud of being able to multitask like crazy. And I think that's okay as long as you haven't traded away the ability to single task very deeply when necessary. If you cannot do that, I claim you are intellectually restricted from accomplishing certain things that are really important. Einstein spent 10 years working on the general theory of relativity. 10 years, that's what he did. And his brain is a lot bigger than most of ours. He had the ability to think very deeply when necessary. Richard Feynman could do that. I think all of us could do that, but it's an ability we have to cultivate, and I'm encouraging you not to throw it out the door just because you feel productive because there's a chat window over here and you're listening to MP3s at the same time or whatever. Close Facebook and when necessary and dive in and stay there until the job's done. That's an ability you're going to use the rest of your life, and it's really important, and I'm afraid we're not cultivating it as much as we need to. And that's one thing that Hamming drew attention to. Oh, this thing at the bottom, it says work hard because 10% compounded yields 2x results. What he's pointing out is, and I noticed this at Intel, you would watch, especially suppose 2 new employees walk in the door on the same day from equivalent educational backgrounds, and one of them works a little bit harder than the other one, okay? Just putting a little bit more into it. You might think that on average, then that person's going to benefit a little bit more than the first one. Not true. They're going to benefit all out of proportion to the first one. Because what it's going to do is going to put them on a steeper curve of accomplishment and learning and experience, and they're going to diverge. Their paths are going to diverge very quickly, and you're going to see that they follow different trajectories through their careers. And it's not because one walked in 2x the other one. He was only 10% more than the other one. But so what I'm encouraging you to do is when you apply yourself to whatever job you're going to do, it doesn't matter what it is, give it everything you've got. Don't back off, because that small difference, I'm tired tonight, I think I'll go home early. Well, if you're going home early to see your family, that's fine. If you're going home early to watch American Idol, that's not as good. It's good to be entertained, and that's fine. But make sure that you're not backing off just because, why bother? That's not a good reason. So it makes a big difference, especially later in your career, because it's compounded. So Hamming also said, you have to be able to give good talks and write clearly, and that's really important today, because almost everyone, if you want to be in an engineering or science career, you will find you need to work with other people. The days of somebody walking off by themselves and coming back with something incredible, that occasionally happens, but don't count on it. That's not normal what happens to people. 1,000 to 1, it's going to be, if you can't get along with a design team or a group of people, if you can't influence them in the way you need to, your effectiveness will be limited. And the way you've influenced people is by talking to them, by sending them emails that they can actually understand, writing memos that explain your point of view to a point where it convinces them. That's really important stuff, and you can learn those skills. They're just skills. They're not something you either have or you don't have. You can learn them, and they're worth learning. Hamming pointed out something that I've definitely realized in my own career was early in the career, you're going to be assigned to things that you may or may not like. You may say, I'm a design engineer, I don't want to do validation. Or I'm a microcoder, and I don't want to do performance analysis. Doesn't matter. If whatever the team needs, then you should do that, and you should be happy to go off and do it because that's what the team needs, not because that's what you need. That's what the team needs so you can get the product done. If you take that attitude and you do a great job at every single task, even the ones you don't particularly care for, it will lead you to a situation where just shortly after that, a couple years down the road, they will come to you and say, what do you want to work on next? Because everything you touch comes out better. I want you on the most important aspects of my new thing because it's got to work, and I know that when I put you in charge, that's how it comes out. That's what you get to, and you really want that. That's the position you really want to get to. The way you get to it is being a team player early on, and that's when Hamming pointed that out. He also said, now, and I don't want to push this one too far, but Hamming also said, if you want to do something, just do it. Don't go ask permission. Don't do EPA studies first. Just go do it, and then go to your boss and say, look what I did. Isn't this cool? You mentioned Jeff Abramson. It's an example. On one of the designs that I was working on, he came in after a weekend and he said, this tool was driving me nuts on Friday. So I stayed up all weekend and I wrote this thing, and look what it does, and maybe you can use it. And I looked at it and said, holy cow, we just paid a couple $100,000 for a tool that doesn't even do that much. So hey, nice job. So we really liked Jeff after that. But there were other people like that. It's that, you don't just come in and ask permission and say, because you're going to get a no. Anytime you show, the odds are pretty high if you have something, you have an inkling that might be a good idea, well, you probably won't be able to present that in a compelling fashion to your boss. And he or she is just going to go, why don't you just stick to what you're doing? We have enough on our plate, But if you just go off and do it, they can't stop you. And that's when some true innovations can happen. Do that judiciously, however. If you apply that to stupid stuff, you're not going to get your job done, your boss is going to be unhappy, you're going to blame me, no one's going to be happy. So this last one you might think is a little weird, but Hamming drew attention to it. He said, a lot of people feel, especially engineers feel, I don't have to conform to society. My brain's as big as anyone here, and I don't, you've always thought I'm a nerd or a geek and I don't fit anyway, so the heck with you. And I'm just going to do what I think is right, and I'm going to wear what I want, and I'm going to look like this guy. And to which I added this caption, what do you mean CEO is no longer in my career path? What Hamming was pointing out was, there are messages involved with what you wear and how you look, and whether you mean the message or not is kind of irrelevant because the person receiving the message is where the action is. So what he pointed out was he used to dress really, really sloppily. And at Bell Labs, if in the 60s and 70s, you had to dress like this. I would have fit in very poorly. I only wore this tie for you guys, I want you to know. I wear jeans. That's one of the best things about being an engineer is you can get away with wearing jeans a lot of the times. But when Hamming was an engineer at Bell Labs, you had to dress up with a tie. and he refused to do it. And he was noticing he was getting treated poorly by the secretaries, by the administration staff, by pretty much everybody. And finally, somebody took him aside and said, that's why they're doing that. They're not trying to pick on you. They just don't view you as important as the people who are playing by the rules here. So he said, well, that's not a battle worth fighting. It's not something that I feel like I have to prove to them, and I'm an individual. I won't let them, throw me around. He said, that's baloney. If that's what they need, then dress to appear to conform. He didn't say conform. He said just fake it if necessary. Just it gets you past this goofy thing. So I thought that was worth passing on. Not that I see a lot of piercings out there, but if you go to our local high school, you will. I think this guy goes to our local high school, actually. I've seen him somewhere. All right, so Tom Friedman. If you haven't read Tom Friedman, I think he's a kind of a cool guy, and he's got some stuff worth hearing. He wrote a bunch of books. The most recent one is Hot, Flat, and Crowded. One's called The World is Flat. He wrote The Lexus and the Olive Tree. He wrote a bunch. They're all kind of fun. They're very entertaining. They're good reads. He spent a lot of time in the Middle East, so I think what he says about the Middle East is well worth reading. But he also has a lot to say about the American economy, our culture, other things like that. One of the things he says is don't sit around waiting for your big break. He thinks he sees a trend, and I'm afraid I do too, of too many people that, like it's the American Idol crowd. Pick me, and if you pick me, I'm a success, and if you don't, I'm a failure. What is that? That means the action's on your part. I'm doing nothing. That's not what built America. That's not what built our industry. It's people going out there and doing stuff on their own. They don't wait for someone else to sort of designate them as the big winner. Nothing happens unless you make it happen. And I think Friedman's exactly right. He also says we need to get back to making stuff based on real engineering, not financial engineering. Now, I thought he was the original inventor of that phrase. We watched the movie Wall Street about 2 days ago at home. And darned if almost that exact phrase appears at the end of that movie, said by one of the main characters. And I said, Tom, you never gave a citation on that. But the sentiment's correct. He also says in China today, Bill Gates is Britney Spears. But in America, Britney Spears is Britney Spears, and that's our problem. I think he's right. I don't know. Whatever. This guy is Dwight Eisenhower. Look what he says about engineers. He says, engineers build for the future, not merely for the needs of men, but for their dreams as well. Thus, inherently, the engineer's work is a fearless optimism that life will go forward and that the future is worth working for. And I think that captures a lot of engineers that I know of. It captures how they view the world. They don't want to just get a paycheck. They're trying to change the world in a positive way. And by the way, this also resonated with me as a parent when my kids were really little. I thought, having kids intentionally is a way of saying, I think we can make it a better place. I think it's going to go okay. I think we have some control over what's going to happen. Otherwise, you wouldn't have kids and have them born into some awful circumstance, at least not intentionally, right? So, that kind of resonated with me when I saw this, and I said, yeah, Dwight's got that one right. Now, some things that I think I've learned is when you get a chance, when you're faced with alternatives and you're not sure which one to pick the best team. Pick the best people. They're going to teach you more than you'll ever learn any other way. Plan your career for the long term. I used to get people would walk into my office just right out of school, and they'd say, okay, Mr. Chief Architect, tell me what I have to do to get your job, because I want your job. And I'd say, well, I'm not sure that's really true. If I had been you, I would not have been able to do this job. I had to do all the other jobs along the way, along my random career, before I knew enough to be able to do this job successfully. If I put you in this job, I think you would fail. Why would you want to do that? That's not fun. You want to do this when you're ready. So the question you should be asking is what kind of career trajectory, what kind of events along it would be best suited to this kind of a job? But you don't literally want this job right now. That's not a good idea. You need to plan for your long term. It's not American Idol. You're not trying to score big the second day of your job. It's not, if you think that way, it's not going to lead you to the right path. I used to tell people this. I actually believe it, fortunately. That true happiness lies in tackling challenges worthy of yourself. I mean, we all know how this game ends, right? We're one of the species that knows we don't live forever. So the question is, what are you going to do when you're on this planet? How are you going to make it worth the time that you spend here? Make it worth your carbon? This is one of the things I think you should do. You should ask yourself, what are my strengths? What am I good at? What can I contribute to this place? And do that. That's what you want to go off and do. And to me, that's the only way you can look back, at the end of your career and say, am I happy with what happened? Or did I just bounce around and watch a lot of TV, right? The other thing is, and this might surprise some of you, maybe not, maybe you guys are all nice to everybody, but I've run into a lot of people that are kind of all elbows on the way up of their career. They're kind of like, I need to get ahead of you, so boom, boom, boom. It's a bad idea. It's a bad idea. It's much better to be nice to people. And I don't mean gratuitously like sugar or like fake. I mean really be nice to people. Because the amazing thing is who can help you at different times of your career. You'll be very surprised by that. It's not just your boss. They ask a lot of people. If you're not nice to your admin, but you're nice to your boss, you're not being nice to anybody. Because they're going to notice. That gets around. Being fake doesn't work. So this is just a generally nice, good idea. So keep it in the back of your head. The other thing that might surprise you, I hope, is that failure is a key to success. But only if you don't give up. If you fail at something and you say, oh, whoops, I must not be cut out for this. This is too hard. Where's my TV? Then you've got a problem. You're not going to get anywhere. But if you fail and you get up and you fail and you get up, you've learned a heck of a lot. And if you apply that learning the third time, you might succeed. I don't know anyone who succeeded at big stuff who didn't fail first. I don't know anyone. I mean, maybe Google, maybe Brin and Page did it. I have no idea. But in general, you have to screw things up first. You have to find yourself flat on your back saying, how did I get here? That plan didn't work. Well, maybe this plan will work. That's the kind of a plan that you have to get where you want to go. Shameless plug, if you don't know about this incredibly good book. There's more stuff like this in here, so I thought I'd draw your attention to it. Pick your targets. Okay, what does the world need? So this is just general. If you're sitting there listening to what I just said, this is my list of what I think the world needs. And I could go on. I only listed about 8 things because the font would get too small if I kept on going. But there's a lot. Every one of these is really important and could lead to worst case, could lead to serious social disruption. Energy, water, food. People aren't real stable. One of the things about the human race is that when threatened with extinction, we don't really go out gracefully. So picture a world in which climate change is making the waters rise in your country and you live in Bangladesh or something. It's not likely that you're going to sit there and say, man, I wish I could swim better. It's more likely you're going to say, gee, I wonder who did this to me and what I can do to show them I'm unhappy with this outcome. And if you believe climate change is a problem, as I do, I think there's plenty to worry about just on that one thing alone. To sort of say, this is not an issue we can safely ignore anywhere on the planet. Energy. Right now, we're doing the world's stupidest thing, and I think we're going to have one heck of a time explaining it to our grandchildren. Why were we using energy so incredibly profligately when we already know that it's causing terrorism and unrest, it's funding exactly the wrong people, it's polluting the atmosphere, it's causing climate change. Come on, there's 1,000 reasons why we should be getting serious about this problem right now. And fortunately, I think we're getting more serious than we were, but it may not be enough. Let's hope that things pick up. Anyway, what I want you to do is not necessarily, I'm not trying so much to convince you that my list should be your list. What I'm trying to convince you of is these are examples of things that I personally think are worthy of a challenge worthy of tackling it. But what I want you to do is make your own list. You should be deciding what you think is worthy spending your life on. When you go out and start working on something, make sure it's worthy of yourself. This is the kind of list that I would have picked. You pick your own, but at least do the exercise. I also want to point out these columns aren't correlated. I couldn't figure out how to map the technologies to the problem. So here's just some technologies that I think are cool and could potentially help. I personally like robotics a lot. I think it's really cool to watch machinery move. I even was impressed by the line printer, if you remember, so it doesn't take much. There's a bunch of really cool things. There's some new technologies coming out for non-volatile storage, for example, or computers, quantum computers, neurocomputers, biocomputers. There are people out there trying to make mechanical brains. DARPA is trying to make a cat brain, like basically silicon that when powered on is as smart as a cat. Why a cat? Because it's not quite dense enough yet to approach a human. Plus, you have to start somewhere, and I think there's a lot of mice at DARPA, but just guessing. But the idea is, now, lest I lose the point because I'm such a funny guy, the idea is you took your list on the left, and once you think you've identified what the world really needs, make another list on the right and say, well, I'm a technologist or I'm a scientist. What am I interested in? What kind of stuff am I good at that could make some dent on one of these? And let's see if there's some way I can do that. Let's see if I can apply myself to one of those things. And that's where I came up. These are just examples. And these lists are by no means complete, and you have to sort of do your own for this exercise to work. I also want to point out that you might think, oh, this is altruism. I'm telling you, you should go be Mother Teresa. Well, that would be good if you want to be. I have no problem with altruism. If you haven't read 3 Cups of Tea, please go do that. I'll excuse you. You can go right now and go read that. This is that guy. There's a guy named Greg Mortensen who was an Oklahoman. He was a mountain climber. He got into a bad shape climbing, I think it was K2, and some village rescued him. And he was so grateful, he said, I'm going to build you a school for your Muslim daughters, because they're the ones that aren't getting educated. And he knew that if you could educate the daughters, the terrorism problem would go down a lot. And he's apparently right about that. He has since built, I don't know, last count it was 56 schools. And he's not a rich man. He's got nothing. He just came back to the States, told people what he wanted to do, got them signed up. And anyway, it's a great book. I encourage you to read it. But I'm not talking about altruism, although I think that's a great thing. What I'm saying is the world, whatever it needs is what it's going to reward. When energy becomes scarce, if you've got an alternative to that energy, you're going to become well-known and well-respected and probably very wealthy. It's what the world needs is going to be rewarded. And that's true of any industry, military, schools, whatever. So my idea was just, no matter what your aspirations is, go through this exercise and think about where you think you can make a dent and make sure that's aligned with your fundamental belief system, because there will come a day when you're going to look back at your own value system and say, have I been wasting my time? If you're on a design team, for example, you put your head down and 5 years later you pick it up and you've finished one chip or one design. And at that point you think, was that 5 years a good idea or was that a waste? Am I just 5 years older? And you better have a good answer for that, because if you don't, you're not going to be stable. You're going to want to jump out of it. You're going to be very unhappy. Something bad is going to happen. You've got to keep track of these things. Another helpful viewpoint, a guy named Eric Anderson said, the most insidious influence on the young is not violence, drugs, tobacco, drink, or sexual perversion, but our pursuit of the trivial and our tolerance of the third rate. So, I think he's exactly right, of course. I hope you picked that up. My point to you is, what are you passionate about? That's what you should do. Because competence is good, and we teach people to be competent. If you just get through your classes, you're going to be competent at something useful. But competence doesn't trump passion. If you're really passionate about something, that's what's going to truly produce world-class results, and that's what you want to latch onto. So that's also probably going to be your point of highest leverage on the world, where you can make the biggest dent is something you feel strongest about and you're willing to apply yourself to. So also be aware, you like my graphics? The internet's my friend. I also wanted to point out your answers will probably change over time as you get older, because your perspectives change, your circumstances change, your experience base changes, everything does. That's okay. That's a natural process. Wherever you are in this process, do the best choices that you can make, and just know that as you get older, you may want to adjust things. That's why you have to do this exercise repeatedly. You can't just do it once when you're 20 and call it good. You have to keep thinking about this. You can find career value in any job. I mentioned that earlier. Just make sure that whatever you're doing, don't do it halfway. If your boss gives you a broom on your second day of work, make that floor as clean as he's ever seen it. That principle is really important, and it will distinguish you from other people. You might say, that sounds really glib. It's easy to say that, of course, do a good job, so what? What I'm saying is look around you. How many people do you see actually doing this? When you go to the gas station, you go to the supermarket, you go to the doctor's office, you go anywhere, watch what those people are doing. Notice which ones are really going all out to satisfy your needs and to do their jobs well. And then sort of statistically say, what's the odds of people doing that? You're going to find out it's astonishingly low. Most people are going through the motions. Don't do that. You can easily put yourself on a better trajectory just by working at it. It's a choice that you're making. So for the conclusions, I think if there's solutions to the world's problems, and you'll notice I put the word if in there. I'm not saying there are. Yes, I'm an optimistic guy and I'm an engineer and I want to go off and fix the problems that exist. But I don't know for a fact that there are solutions to all of the problems we've got. I never want to assume that. I think it's dangerous to assume that. I'm afraid that, for example, Congress will say, or the executive branch of the government will say, we don't have to quite get serious. Now, I'm not picking on Obama, by the way. I like the guy. But I'm just saying, I don't want people at that level of the government saying, I don't really have the money right now to look into alternative energy, so I think we probably have enough to get by for a few more years. So let's put this off for 10 or so, maybe 20, and then we'll get back to it. And then we'll get a solution when we need it. The technologies have never let us down before. They won't let us down this time. I think that's really dangerous. If we set ourselves up for that, what if there is no technical solution down some of these paths? What if they give you coal and say, I need really clean coal, and I need it tomorrow. So all you chemists, go off and fix this. You come back and say, if physics is rigged against me, I can't really unroll it just because you don't like the outcome. You have to have time, you have to have energy involved in these things, and you have to make sure that if you don't get commissioned to do something that is literally impossible. So that's the only reason I put the word if in there. I think if there's a solution, we're going to find it, but don't assume there's one. Watch what the Steelers are going to tell you. You know, the fundamentals. It's the fundamentals. Get them right. Play every play like you're Polamalu, right? You never see him sort of loafing out on the field. He goes after everything. Make sure that the other team doesn't win by default just because you didn't show up or you were too tired or your cool song was on the iPod. You know, make the other team earn it. And remember about the competition thing. Respect your opponents, but not too much, because otherwise you'll psych yourself out of the game. If you lose, figure out why and fix it. And get out there and compete and never give up. And that's my message to you guys. Any questions? Q&A. Back to work, Stacy.
Back to work. Actually, I want to lead off with something that we talked about earlier today, and that was addressed midway through your talk, but in finding balance. And you talked a little bit about that, and how you balance what you're doing in your work and the other aspects of your life. If you want to address that.
Yeah, thanks. I was speaking to some students this afternoon, and I left off the punchline, but I'll give it to you now. The question was work balance versus home, family, and I found it to be one of the most difficult things to get right. I'm not sure I ever did get it right, but fortunately I have a forgiving spouse, and forgiving kids for that matter. But the issue is, okay, I've already exhorted you to apply yourself full blast to whatever technical challenge you decide is worthy of you. Once you've done that, it's really easy to forget your spouse, to forget your kids, to kind of lose track of what's happening on the home front, just assume that's going fine while you're at work all the time. That often leads to divorce, and you don't want that. So my message, the sort of the punchline is, yes, you have to balance the two, and it's really good to get your spouse and your kids interested in your work, because that helps. Then they'll understand why you're not home when they wish you were. But in the end, when there's a trade-off and you have to make it, family has to win. You don't sacrifice your family for your work. You just don't. It's more important. You have to balance. I mean, you've got a set of values in your life that have to do with how you view your spouse, how you view your kids, how you view your creator. You've got to balance those things and get them right. If you screw those up, no amount of work is going to satisfy you. It just won't make up for it. So, as a project manager, I know that if I run a project for 5 years, and I have 800 people working with me, statistically, there's going to be a couple divorces in there. And that's going to bother me, because I'm going to wonder, did I put a little too much pressure on that guy? That time that I said, gee, the deadline's Monday, I'm counting on you, you spent the weekend, was that when it fell apart? I don't know, and I don't want to be in a position of having to second guess that. So I gave this same pitch to all of my engineers at Intel, specifically to try to help them not make that error. I would tell them, look, this is a 5-year project, but your spouse is forever. If you screw this up and you lose your spouse, you're not going to be happy at work. You're not going to do a good job there either. So, I'm passing that on to you guys too for what it's worth. Make sure you get that balance right, and make sure you don't think it's 50-50, because it's really not.
Other questions?
Everyone's asleep? You look awake. Yes, Roger.
So, there's been talk everywhere about the fact that single processors are not really getting any faster. And so what do you think is going to happen?
Short term or long? I'll give you the short term, because long term is way too hard. I think short term, you're going to still see companies like Intel and AMD turn out chips with more cores on them. Not because they think the world wants those, not because there's some incredible user demand for those, but because those are the only way they see to maintain the architectural franchise that they've already got. Those cores are x86 compatible. You'll notice that when they put out like Larrabee, for example, and there's 40 cores on there, every one of them is x86 compatible, because they are afraid of a universe in which those become dedicated units or someone else's architecture. In that kind of a universe where they're not x86 anymore, they have got no built-in advantage over anybody else. And so suddenly the competition field is wide open to a lot of people to play that they would really wish would stay off the field. So Intel and AMD, when you've got so alternatively, maybe it's a different way of looking at the same thing. If you have a really valuable franchise, as Intel has had for decades now, you don't give it up without a fight. And this is the fight. This is what they're doing. This is they're stretching it as far as they can until the cow just doesn't give milk anymore. And so while they're doing that, and by the way, so that's almost a cynical way of looking at it. A less cynical way would be, well, this is still a technical avenue that is still open to us because the single thread thing kind of got killed by power. And we can still go multi-core if we do it intelligently. And we can stretch that out for at least a few more years. We can go at 6 cores, 8 cores, 10. We can probably get up to 12, 16 without really breathing very hard. But power is going to remain a first-order constraint on all of that. And the programming problem is enormous. We have this huge installed base that if you just apply it to a 12-core machine, one core is going to be real happy and the other 11 are going to be watching American Idol, right? What else are they going to do? So we have a programming problem. We have to figure out how to map single-thread applications that have always historically existed in a useful way, in a correct way, onto the multiple cores, no matter how many there are. And that's difficult, both because there's multiple cores and because there's an unknown number of them. That's the tricky part. Like if you always knew that you had some number of engines in there, you could at least find some way to partition the problem so that it kind of partitions properly. But if you don't know how many there are, it has to sort of figure that out on the fly, and it has to run well no matter how many there are, and that's doubly tricky. So I think there's a huge programming problem that the industry is kind of trying to find its way through right now, and it's not at all clear that there is a solution, much less what it is. I just know there's a huge motivation to find it if it's out there. So I think at least for the next 5 years, you're going to see more cores. One other thing, the voltage scaling problem. The voltage scaling thing that we've always done in silicon, we used to go, CMOS used to be 15 volts to run it, 15-volt battery or whatever. And then it went down to what, 10, and then it went to 5, then to 3.3. We're currently running the chip like inside this laptop at about a volt, and it's going to go down to about 0.9, but it can't go much less than that because the physics doesn't like that. It makes either you go too slow or the leakage goes up too high. So you don't want to get that far down, and to avoid it, it means we're going to flatten out, no longer get a benefit from voltage scaling. That also means power is going to try to go up. Well, it can't go up because air cooling prevents it. Well, then you have to take it out of the clock rate and other things. So you're being constrained in two new ways that we've never had to compete with before, or contend with, I guess. So because of all those reasons, I think even the multi-core plan is going to run into serious issues. I also think that CMOS is reaching the end of its road as a technology. There's several warning indicators that that's becoming the truth. One is the size of the oxide thickness, the number of atoms that are in the oxide thickness. When they get down to numbers that you can count, like 7, suddenly all you see is quantum mechanics. There's no longer the classical stuff that used to make these things work. And then even below that, there's a problem where if you inject the dopant into the silicon so that you get semiconductors out of the stuff, historically, statistics was your friend. You would try to stick 1,000 dopant atoms into something, and if 900 of them made it, you're in good shape. If 500 made it, you're still in good shape. But if you're trying to inject 50 and 0 make it, you're not in good shape. Now you've got an insulator instead of a semiconductor, and it's bad. And worse than that, the transistor right next to it on this 2 billion transistor chip, it might have gotten all the dopant, and he's still happy, he's still working. Now, how do you design a chip so that every other transistor is kind of flaky? We don't know how to do that. We don't have those techniques. And even if we did, why would you want to stick 2 billion transistors on a chip if only 1 billion of them are going to work? It's kind of a questionable thing. It means you might have gone too far on Moore's law down the CMOS path. So I'm afraid that there's going to be some. That was the pessimistic story. The optimistic story is that every time something like this has happened in the industry, a lot of money and a tremendous amount of cleverness got applied to it, and they killed the dragon, and they kept on going. That historically has been the case, and I bet they're going to kill at least one more dragon before we're done, maybe 2. But ultimately, the dragon's going to get us, and the question is when, and that's why I don't really want to deal with long term, because that's a lot harder. I just know for the next few years, you're going to see more cores, and with ever increasing amounts of money available to teach someone how to program them. Yes, sir.
Do you have any insight from having to work on a project that's largely complex to the processor and still come out with a quality product?
I hope so, because that's what I was in charge of. The alternative is I lucked out, which is a plausible argument, but I used to worry about that a lot, actually. It's when I started these projects at Intel, that's when I was most worried about it, because I thought, if you take all of the trends combined, the amount of complexity, the amount of power, one of the ones I didn't anticipate before I got to Intel was the size of the software you have to be compatible with. Like in 1990, the PC industry had really only just gotten started, and there were maybe, I'm going to make a number up, there were maybe a few hundred programs that I had to care about, applications that I had to run successfully. But by the late 90s, that pile was hundreds of thousands. It was huge, the amount of programs, any one of which, if it failed, could kill me, right? I put a piece of silicon out there, and it's required to run every one of those. Well, how do I know it does? I can't test them all. So you say, well, as long as you design to the architecture spec, that should be enough, right? No, false. Example, inside the architecture spec, there are places where it says this condition flag is undefined as a result of this operation. So you'll do, I don't know what it was anymore, an add operation or something. No, it can't be add. Pick a different one. There was some instruction that would say, I do not guarantee what the carry flag will look like when I'm finished. And you go as an architect, hey, that's cool. It means I can do it either way, whatever way is easiest. No, it doesn't. If you think that, you're going to get in big trouble. Because what will happen is, and this literally happened, which is why I know about this, you put the chip out, and then you discover, oh, it was easiest for my team to set the bit to a 1. Didn't matter, because it was undefined, right? I get to pick. But all the previous chips were setting it to a 0, although they were calling it undefined. Now you're in trouble, because what you're going to discover is some goofy app out there required that the bit be a 0 after that operation, even though the book said it was undefined. And they didn't notice, because up until now, it always was a 0. But your chip comes out and the software doesn't work anymore. Guess who's at fault? You are. And you go, hey, look at the book says, can't you read? And they'll say, I don't care what you say, your chip doesn't work my software, you're a loser, your chip is busted. So I had a couple of issues like that, and we had, fire drills to go up. What do we do about this? Well, you can patch it in software, or you can fix it some other way. Worst comes to worst, we'll fix it in the silicon, because that's the most painful, expensive one to do it. But all I'm saying is it's a much trickier game than it looks like. So pretty much playing every technique we could think of was my answer to it. We did some formal verification. We had huge validation teams. We incentivized people, but carefully. Like, you get really nonlinear effects if you incentivize validators a little too hard. And designers too. If you tell a designer, for every design bug you find, because here's the motivation, right? You say, if I find a bug at the design stage of a project, it costs me, $1. If I catch it at the validation stage later, it's $10. If it gets out into the public, it could be $1,000 or worse. So I'm motivated to find it at the design stage. Okay, so I'm a smart engineer or smart manager. I'll incentivize the design engineers to catch their own bugs. How do I do that? I know, I'll give them $100 for every reported bug that they find and fix. Did you see this in Dilbert? It was in Dilbert. I swear it was in Dilbert. What was the guy? The guy that drinks coffee and he's always very cynical? Wally. Wally said something like, oh, I'm going to go design me a new minivan. And I went, uh-huh. That's because you got to be careful what you incentivize people to do. There's no easy fix for all this. And by the way, so I also had a fight with upper management at one point about validation on our chip on the Pentium 4. And the big boss, I was at the board, kind of like this, and he said, how many bugs are you going to have in the Pentium 4? And I said, oh, geez, I don't know. I mean, we haven't even put it out yet. But the P6 had about 150, and this chip's about 3 times more complicated. I'm going to go with 500. Which I just made up on the spot. And he just panicked, and he freaked out, and he said, you have no project. Just stop right now. I said, oh, that's kind of harsh. 400? But then he said, well, this other project is going to have 25. And I said, 20? How do you know that? Did God tell you that? Because I was hoping he'd say yes, but no. But he said, no, the team has committed that to me. I said, how on earth did they commit that number to you? How did they know that it was what? And he said, because they've done formal verification, and that's what it said it's going to be. And I said, as far as I know, formal verification cannot possibly tell you that. They can tell you that there's a bug. It can't tell you there's no bugs. And it sure can't tell you how many bugs it missed. That doesn't make sense. I mean, but he said, well, that's what they committed. Unfortunately, this is why they should have fired me. I said, well, then they're idiots for telling you that, and you're an idiot for believing them. That probably wasn't wise. I don't recommend that. I mean, he would have been within his right to fire me. Later on that day, that same guy, we had a private meeting, and he said, you can't call your boss's boss an idiot in front of 50 engineers. And I said, that was rash, and I apologize. I was out of line for saying that, but I was right. Anyway, yeah, I don't know. All I can say about validation is you've got to throw every trick you can think of at it, and you have to know that it won't be enough. I also think you have to take into account, while you're trying to design it anything, software, hardware, doesn't matter. You're trying like crazy to design it so that it's perfect on the first go-around. Some other part of your head has to also be secretly plotting, knowing that it won't be, and trying to take into account, well, what will I do when it's not? What should I be doing now to allow for a future where it's not quite perfect and I need to deal with that? If you can't do both those things at once, you're in big trouble. So as an example, in all the chips since I was there, one of the things that I added to the Intel's micros was what we called the microcode patch facility. And the idea was, after the fact, even in this laptop for that matter, when it wakes up, it checks the BIOS ROM and it tries to decide, do you have a patch for me for my microcode? And it pulls the bits off the ROM, does a bunch of crypto checking on them, and if they pass the test, it adopts them as a fix for the microcode. And from then on, every time the microcode hits a certain address inside, instead of executing that microcode, it jumps to this new stuff, does that instead, and jumps back. So that's why it's like a Band-Aid. But it allows you to work around bugs that you find later without having to recall the silicon. Now, of course, it's got limits. If you get too many bugs, you're going to fill up the microcode patch facility, and you're still screwed. You still have to get another chip. But so far, so good. That hasn't happened, and Intel's been using this facility ever since. So now that I've told you that, I will also hasten to point out AMD has not done this, and yet they have not had huge recalls. And yet they've got chips of roughly comparable complexity. Now, I don't know what that says, about the two teams, the two companies, or whatever. I just wanted to point out that, I think the code facility, the patch facility is a good idea, but there's at least one other company out there that doesn't seem to think it's necessary. Multiple paths to the same goal, maybe.